Welcome back to Gyan Byte. Last time, we showed how CSRF tricks your browser into sending requests you never intended. Today, we go deeper. The same origin policy and CORS. The same origin policy is the most fundamental security boundary in the browser. Every cross-origin fetch, every iframe restriction, every cookie rule, it all traces back to this one policy. Break it, and the entire web falls apart. We'll break down what an origin actually is, see what the same origin policy blocks and allows, understand why CORS exists, walk through simple requests and preflight, and cover the misconfigurations that open real security holes. Let's go. Before we talk about CORS, we need to understand what an origin actually is. An origin has three parts: the protocol, HTTP or HTTPS, the host like example.com, and the port like 443. All three must match for two URLs to be same origin. Let's compare. HTTPS example, com port 443. That's our reference. Same protocol, same host, same port, same origin. Change the protocol to HTTP, different origin. Change the host to API. Example.com, different origin, subdomains count. Change the port to 8080, different origin. One mismatch in any of the three parts, protocol, host, or port, and the browser treats it as a completely different origin. No exceptions. So what does the same origin policy actually block? When JavaScript on page A tries to read a response from page B, and they are different origins, the browser blocks it. A fetch call to another domain? Blocked. Reading an iframe's content from a different origin? Blocked. Accessing another Windows DOM? Blocked. But here's the thing, the browser doesn't block everything. Images load cross-origin. Script tags load cross-origin. CSS style sheets load cross-origin. Form submissions go cross-origin. The browser blocks reading responses, not sending requests. That's a critical distinction. SOP blocks JavaScript from reading cross-origin responses. It does not block the browser from sending cross-origin requests. That gap is exactly what CSRF exploits and what CORS was built to solve. If the same origin policy blocks everything cross-origin, how does the modern web work at all? Your frontend is on app.example.com, your API is on api.example.com, your CDN is on cdn.example.com, different origins, all blocked by SOP. This is exactly why CORS was created. Cross-origin resource sharing. It's a protocol that lets the server say, I trust this specific origin. Let their JavaScript read my response. The server opts in, the browser enforces it. The browser sends the request with an origin header. The server responds with access control allow origin. If the origins match, the browser lets JavaScript read the response. If not, blocked. CORS doesn't replace SOP, it's a controlled exception to it. CORS is the server telling the browser, I trust this origin. Without it, the same origin policy blocks the response. For simple requests, get, head, or post with basic headers, the browser just sends the request directly. No preflight, no extra round trip. The browser adds the origin header automatically. The request goes out with the origin header. This tells the server where the request came from. The server checks this origin and decides, do I trust it? If the server trusts this origin, it responds with the access control allow origin header set to the requesting origin. The browser sees the match, origin matches the allow header, and lets JavaScript read the response. But if the header is missing or doesn't match, the browser blocks JavaScript from reading the response. The request still went through, the server still processed it, but your code can't see the result. That's SOP enforced via CORS. Simple CORS, browser sends origin, server replies with access control allow origin, match means access, no match means blocked. Not all requests are simple when you use put, delete, or patch. When you send custom headers like authorization, when you set content type to application by JSON. The browser has to check first, can I actually make this request? That check is the preflight. Step 1. Before sending the real request, the browser sends an options request to the same URL. It includes access control request method, the method it wants to use, and access control request headers, the custom headers it needs to send. Step 2. The server responds saying which methods are allowed, which headers are allowed, and how long to cache this pre-flight result. If everything checks out, step 3. Now the browser sends the actual request. The pre-flight already cleared it. 2 round trips instead of 1, but the server explicitly opted into every method and header. Preflight adds a round trip, but it guarantees the server knows exactly what's coming. No surprises. CORS is only as strong as how you configure it, and these 3 mistakes open real security holes. Mistake 1. Using a wildcard access control allow origin set to star. This means any website can read your API responses. If there is no credentials involved, maybe that's fine for a public API. But the moment you combine it with credentials, the browser actually blocks it. Star plus credentials is explicitly forbidden. Mistake 2, and this is the dangerous one. Reflecting the origin header back as the allowed origin. Whatever origin the request comes from, the server just echoes it back. This means evil.com sends a request. The server responds with allow origin evil.com with credentials enabled. That's a full CORS bypass. Mistake 3. Allowing the null origin. Sandboxed iframes and local file requests send origin null. If your server trusts null, an attacker can craft a sandboxed iframe that makes authenticated requests to your API. Never reflect the origin blindly. Never trust null. Use an explicit allow list of trusted origins. 5 concepts. 1 security boundary. Origins, protocol, host, and port. All 3 must match. The same origin policy. The browser blocks JavaScript from reading cross-origin responses. CORS. The server opts in by setting access control allow origin. Simple requests go straight through. Complex requests need a pre-flight and options check before the real request. The rules: use an explicit origin allow list, never reflect the origin header, never trust null, and always validate on the server. CORS is a browser feature, not a security guarantee. Next up, Content Security Policy, CSP. The header that controls what your page can load, run, and connect to. Subscribe so you don't miss it.